Thank you so much. Hi, everyone. It's a pleasure to be here with you today. My name is Pietro Casella. I'm joined with Erik from our team. We come from EQT, which is a private equity firm very focused on sustainability and digital. And at EQT Digital, which is one of the parts of the company, we actually have three missions. One is to run a state-of-the-art stack. Secondly, it's to find companies to invest in with artificial intelligence. And thirdly, it's to help those companies actually become digital leaders in their industry. So private equity is not your typical, digital forefront company. It's actually quite a laggard industry. But 5 years ago, EQT decided to change that. And so when I joined EQT, we made a fairly big bet on becoming top class in digitalization. So this is a mission that presents itself to many companies, but in our case, I think it was very, very sincere. But we as architects, we had to translate that vision into actually, concrete goals and concrete things that we had to build. So we started listing what it meant for us to be a digital leader, and it included things like automation, data centricity, using AI, moving to the cloud, all of your buzzwords. But it was really sincere. We had a background from other companies. We saw that this was actually possible. So we decided to do this. We had to do it. So for the next 2 years, we actually spend most of our time working on the foundational stuff, so moving stuff to the cloud, ERP implementations and whatnot. But then we reached this point where we had to start investing quite heavily in data and process automation, and also on the long-term team dynamics that we wanted to achieve. So luckily enough, this is more or less when I found DBT and I got introduced to all the modern stack. And we came up with a strategy of how to achieve this in a really smart way. So the strategy starts with a question, which is, what if we put a DBT at the center of our architecture? So that's kind of the main thing we wanted to achieve. What does that mean in terms of in practice? How do we actually achieve that? Well, we established a number of principles for our teams and for like our product strategy, which included things like making sure that every application was putting data into the data lake. And we wanted teams to actually curate this idea of a public data API, which is basically, the representation that makes sense for others to use. We wanted anyone at our company to be able to use this data, each other's data, to build stuff. So this was kind of the embryo of this concept of exposures that is live today. We also wanted the business logic to live as much as possible in DBT, and we'll explain why this is important. And also like this principle that everybody can use DBT. Okay, so this is like how we thought the concept could be translated into principles. Then, of course, we had to challenge this, and so we asked ourselves, okay, why should we do this? What's the hypothesis? Well, we compared the alternative, which would be to let each team basically start building a lot of these automation principles in their own stack. And we thought that the alternative would be much more complex, much less lean in the sense of like a lot of duplication of data pipelines and stuff like that. And there would be a value leakage in the sense that if you don't have a clear incentive to expose your data, no one else will use it, right? And with DBT, everything was kind of the opposite of this. So it was very simple. Everybody can use it, very well governed. This is important for us to make sure that we understand the dependencies of data and what is feeding what. And finally, we expected this to be a value booster. So something that would fuel the value we get out of our data. So we fast forward to today. Basically, we managed to have pretty much every team on board. So I'm talking technology teams. And these teams have been working on a number of use cases, which is what we'll show today. So there was a comment on our talk before, which was funny. We said, everybody has 7 or more use cases for DBT, right? And we agree with that. So, but most of the time, I think we see those use cases as part of this larger use case of business analytics, right? So for us, we start with this not only because it's like probably the obvious place to start, and we started doing a lot of stuff like financial performance management with DBT. We entered a little bit into the automation front when we looked into measuring business process performance across applications, something that we really like to do. We started introducing concepts of self-service, to have teams generate some self-service use cases. And we did this for a reason. The main reason here is to create an incentive for the curation of this data API. So this core principle that your data is exposed to be used by others. Business analytics generates that. The second use case has to do with reliability of data. So coming from a past where the company was not relying so much on the data warehouse as its source of truth, we had to create mechanisms for the certification and the propagation of those like trustworthiness properties downstream. So we implemented this use case. Basically what it is you have all your data collected on the data warehouse, and then we export that data into systems. In this case, the example is Anaplan or a master data management system. The data is then enriched by humans there. So either they're kind of doing deduplication of records, or they might be certifying certain aggregates by saying, okay, this total number is correct. And then that data goes back into the data warehouse. And with that certification tag, with that human element, it gets propagated back into the business analytics use case. So what we achieve with this is this idea of trustworthiness. So you can serve data to your consumer and say, this has been verified. But more interesting than that is the idea that you can actually use this human input for automatic testing. So you can check, did my aggregate change? So for example, if a developer changes a formula, you can actually catch that the attribute that was certified by a human is actually changing. So that's the nature of this use case. Now for the AI, Erik.
Yeah, sure. So thank you. So before we jump into the third use case, let's add some context to how we use AI by having a quick look at our Motherbrain platform. So it is a tool developed for finding great people and companies to invest in. And it's used daily by our investment professional to make it easier. We built it to make it easier for them to collaborate on and assess interesting opportunities. It has been used to find 9 of the portfolio companies that we have in those funds. It's powered by more than 40 different data sources, as well as the data that is generated by our users. And we're currently tracking around 14 million companies here. We have trained and deployed a number of machine learning models to leverage this data to score companies according to a number of features. So data prep, what is that? Most of you have probably heard that around 80% of machine learning is data preparation. So if that's the case, why not use a data build tool? So we use dbt mainly for feature engineering. That is to say, we extract structured columns from our data to be used as input to our ML models. And before we started using dbt, most of our features were generated by writing a lot of queries in BigQuery and then validating them there, see that it works, and then stitching those into code. I mean, it's a pretty standard way of starting a machine learning project. But it also doesn't take long before you realize that the experience is not the greatest. You get these huge bloated mega queries that are really hard to introspect. And you also have a pretty heavy copy paste kind of workflow going. And you will probably also run into some data quality issues. You're going to be uncertain if the features are actually the same as you expect them to be, or if the data is there, or the features are, yeah, according to what your expectations. If you use dbt, you can alleviate a lot of this because it gives you the ability to materialize different steps of the data wrangling efforts, and then after that you can run tests on them. You're still going to have a bit of a copy paste workflow, but it's going to be much easier because of the modularization. It's going to be much smaller. And you can also, it makes it really easy to materialize features at a certain point in time. And this is cool because it allows us to go back and look at what we know are good deals and then see, would we have found this at this point in time with the data we had available then? But I think the main takeaway for us is that we've noticed quite the improvement of iteration speed of model development with the ability to introspect and explore the features in their different stages of refinement. Yeah, so let's move on to the fourth use case, which is feeding bots and integrations. And so how do you feed a bot? Usually you need some kind of activation criteria. It can be the arrival of new data on a message bus, or maybe a scheduled activation of a query or an API call. A common scenario is that we have multiple bots or applications listening to a service bus. This will most likely mean you have business logic spread out over those apps and probably a lot of code duplication as well. It comes with a lot of plumbing, and we need logic to materialize the messages to a desired state before we can do the integration calls. What we choose to do is to use DBT to expose the business logic directly in our data. This means that this makes it so that both code and its responsibilities becomes a lot more simpler. I mean, it's just basically consuming a view, right? And there's only one point of integration, which is our data layer. And all the data that you need for the integration calls are already there, materialized, ready to go. I guess the trade-off for this setup is that we need orchestration tools like Workato or Airflow to trigger the workflows. And because it relies on this scheduled approach, it's not really feasible for near real-time workloads. But I do want to highlight one of the use cases we use DBT for in this way, and that is to assign companies each week to our investments professionals. And it's a workflow we call Mother Brain as a Boss, or MOB for short. And it has been an integral part in how they work with assessing companies each week. But the main takeaway from this is if you want robust automation, you need robust data, and that DBT can definitely help you with. So the sixth one, computational engine. Well, what do we mean with that? So we can imagine that we have a system with a user that wants to do some action and compile a report on data that is not readily available in that system. It doesn't have the functionality to do that. We can also imagine that the data needed for the report is sensitive or protected in some way. And so we can only use it in an obfuscated manner. We really want to avoid sending sensitive data around to other systems. So instead, we can use DBT exposures to safely materialize and only send the data that you are allowed to share with other systems in a way. So we effectively extend the system that the user is working in. We can also use it in its reverse form, so we can have data enrichment in our own data sets. So we can have, let's imagine we have a third-party application that does something with data that doesn't really conform to our business logic. Then we can just ingest that data and do the necessary transformations in our own data layer so that it does conform to it. And with this setup, we can keep the bulk of the data transformation or business logic in our data layer, and then just use third-party software, mostly just as input. And this allows us to rely on simple systems that do a few things nicely rather than wholesale solutions. So let's have a look at the sixth use case, Pietro.
Yeah, so the sixth use case has to do with the ingestion of complex formats. So at EQT, we are a very large consumer of banking data. So we have something like 3,000 bank accounts. And one of the characteristics of the banking data is that even though it runs on a fairly common standard, actually a couple of standards, these standards are interpreted freely by different banks. So you might go for a bank and the same field has a different structure. So keeping up to those interpretations is fairly hard. And we had two options. So either we could buy a vertical solution and basically delegate the solving of that problem, or we could build a pipeline that would kind of process these files in flight and then save them in a normalized fashion to our data warehouse. So we actually chose to go with a third approach, which is basically to ingest all those files directly into the data lake with no processing, and then use the DBT, use the concept of schema on read applied to this use case to make sure that we convert those different formats into the logic that is today the right logic for us. This allows us to, for example, not have to reprocess all the files when something changes, but rather make a small change in the business logic and then visualize all of the data set, applying that new knowledge. And of course, there's governance aspects to it, which we quite enjoy. So what are the main benefits of this approach? Well, basically, we were able to start exploring much faster. We didn't have to procure systems or anything. And it gives us this flexibility to be really fast and adjusting to these small banking nuances. And also it allowed us to delay the understanding of the business logic itself. So we didn't have to kind of spend too much time analyzing up front. For the final use case, it's about using DBT to feed our customer-facing portals. So a customer-facing portal is fundamentally a way to serve data that you already have, that already exists in your environment, but sending it in multiple channels, right? In our case, it was particularly so because our industry, users don't interact too much with data. They're mostly consumers. So we took some inspiration from the current trends of headless CMSs, and we asked ourselves, what if the data warehouse could be our CMS for this portal, right? Because the data was there, no need to like copy it around or anything. What did we have to do to achieve that? Fundamentally, we had to resort to one of our previous use cases and include these elements of data certification. So what you want to do is be able to verify the data before you actually release it to the public and do some sort of checks or additional aggregations. But then once the data quality is there, you can basically rely on it and have a much shorter cycle with less complexity. So why is this important? I think this use case is key because we see that the more you create utility or the more consumers you add to your data and the more eyes you have on your data, the more the quality goes up, right? So in order to achieve this, we actually had to kind of rethink a lot of aspects of our model, but that was beneficial not only for this use case, but also for a number of other use cases that now can rely on this certified data set as well. So coming back to our initial hypothesis, and we're reaching the end, I hope we kind of proved that this idea of DBT at the core as an architectural principle is good. I mean, we have a lot of code in production following this, and so far we are pretty happy with it. But if you think back about each and every use case, the relevance of it is really this insights box, where we highlighted that if you create the right incentives in the right place, you can start building upon those incentives to do more stuff. And as an enterprise architect, what I think it's important as well is that you're top of mind for solving some of these use cases becomes DBT as well, rather than like the typical go-to things to solve them. That said, I think that this doesn't come without certain caveats. So if you decide to try this out on your company, it's important that you are aware that the data quality becomes extra important. So like all of these use cases rely on it. So you really need to be very diligent. Also, latency issues, as I said, there's a lot of round trips, and round trips mean extra time. So if you're like interested in real time, perhaps this is not the first choice. And also documentation is extra important. So right now, I think we are in the thousands of models in DBT. So it's very important to get that right. And in our case, it was like a blessing to see the exposures feature, because now we can actually start tracking also the consumers of our final views. But Erik, what do you think about the benefits? Do you think they're more than these caveats or these drawbacks?
No, I mean, I think it's a bit more than that as well. Because currently as it is now, we have the Motherbrain team and the rest of the data set has been a bit disjointed. And I think that by bringing this type of technology into our stack as well, we got introduced to it by Pietro, for example. We have kind of started to bridge that gap a bit. And I think we have gained like way more understanding for each other's problems. And we've also found like a lot of really cool opportunities and for future projects that we want to do. And yeah, I think this is really one way of trying to bring together data and get the whole organization to look at how we're like, what is data for us? How should we use it? How will we utilize it? So I think it's a great way to bring that into the company as a whole.
Cool. I totally agree with that. And for me, the most important thing is that we actually saw this explosion of innovative ideas, because it's so easy. I mean, our hack weeks or hackathons, people just connect to the data and start using it. And new use cases come up every day. But most importantly is that we managed to reach this initial goal of becoming like a digital leader in our industry, and we kind of checked all the boxes of that initial hairy goal that we established. And that's it for us. Thank you very much for listening in. If you liked working with this type of stuff, or you want to chat more about it, just reach us on Slack. We're more than happy to meet you.